Dear student, today I am going to discuss about bottom-up parsing. In that, I'll be discussing about shift-reduce parsing. As I said earlier, there are two types of parsing in case of parsing that is concerned. One is top-down parsing, other one is bottom-up parsing. We already discussed about top-down parsing, and today we'll be discussing about bottom-up parsing. So what is bottom-up parsing? A bottom-up parser is nothing but creating a parse tree for a given input string in the reverse order, that is from the bottom to the root. That is, we are generating a rightmost derivation tree in the reverse order. That's why it is called as a bottom-up parsing. That is, for a given string, so we start generating the parse tree from the bottom and we'll read the starting symbol. A bottom-up tree is, as I said earlier, try to generate the rightmost derivation tree in the reverse order. For the given string W, we generate the tree in the reverse order, and we try to read the starting symbol. So in bottom-up parsing tree, we call it as a shift-reduce parsing. There are basically it has two main actions. One is the shift, the other one is the reduce. So what this shift does is the current symbol in the input string is pushed onto the stack, whereas my reduction, at each reduction step, the symbol at the top of the stack will be replaced by a non-terminal at the left side of that particular production. So it means, so in the case of shift, I shift an element onto the stack. In case of my reduce, I try to match the right side of the production to the left hand side of the given production. If the right side of the production matches, that will be replaced by the left hand side of the non-terminal symbol. That's why it is called as a shift reduce parsing. So there are two more actions. One is the accept, the other one is the error. We say that if at all, if you're able to read the starting symbol from the bottom to the root of the tree, we say that the string has been accepted successfully. Otherwise, we say that string cannot be generated by using this given grammar. That's why it is called as an error. So for example, if you consider a given grammar is this, and the input string is this, that is A, B, B, and we are supposed to generate a rightmost derivation tree in the reverse order for a given string. That is, we're supposed to reach from A, B, B to S. So in case of this, how it works is, see, my rightmost derivation string is A, B, B. Now I have to generate from right to left. My first handle, that is the first symbol to be replaced is A, will be replaced by the left hand side of the production, that is A. So then this becomes A. I have replaced this A by capital A. Then the previous right sentential form becomes A, capital A, B. Now my handle, that is the string which is matching to the right side of the production is A, that will be replaced by A. My next right sentential form becomes A, B. Once again, in case of this, so B becomes the handle, that is B will be replaced by capital B. My sentential form, it becomes A, B. So this A, B will becomes my right side of the production that matches to the A, B. So then I'm going to replace this as S. You can just observe that in case of this, we did not replace this A by A. If at all, if we do that, then you will not get the right side of the production, which is having A, capital A, B. That's why we did not replace this A by A. Instead of that, we replace this B by capital B, so that we get A, B as an handle to replace it by S. So this is why it is called as a shift reduce parser. So in case of this, we are shifting A and input string, and then we are reducing to the left hand side of the production. How do we come to know that which particular substring on the right hand side should be replaced by the left hand side? So that is why it is called as a handle. So informally, a handle of a string is a substring that matches the right side of the production rule. So if you just observe in the previous case, so this, in case of this, so A is an handle, then A becomes an handle, B becomes an handle, then finally A, B becomes an handle. So it is called as an handle. So, but not every substring matches the right side of the production rule is an handle, because you could have observed that in previous one, even though we find the A is a substring, but it does not becomes an handle, because if I replace small a and capital A by a capital A, it may not generate me the previous right sentential form. That's why every substring will not become a handle. So what is an handle actually? Now, if at all, if I consider gamma is one right sentential form, so in case of that, if at all, if I have my gamma consisting of alpha, beta, w, then if I can able to replace this beta by left hand side of its production, that is capital A, then I'm going to get the previous right sentential form. Then we say that beta is a handle which will be replaced by capital A. That's what it says, that where the string beta may be found and replaced by A to produce the previous right sentential form in the rightmost derivation tree. So if I handle beta, this will be replaced by capital A, which is on the left hand side of the production. So then this beta becomes a handle of this particular gamma, and it is going to generate the previous right sentential form. So if I replace this A, or you can say that gamma, this entire thing becomes gamma, once again a right sentential form. If I handle this, then it is going to give the previous one. If we continue with that, we'll be able to reach the starting symbol. That's why here beta is nothing but an handle. Once again, maybe A becomes an handle for the previous right sentential form. So if the grammar is unambiguous, then every right sentential form of a grammar has exactly one handle. So it means that you may not find more than one left-hand side of the production matches to the same handle in case of an unambiguous grammar. If it is an ambiguous grammar, so then you may find this beta may matches when you may find this beta more than once on the right side of the given production. What is handle pruning? A right mode derivation, the reverse can be obtained by handle pruning. So handle pruning is nothing but, so if at all, if I consider this as my right sentential form, so the last string is W, and if I get this input string W, so then in case of this W, so previous to that, it is nothing but gamma n. If I replace, in case of gamma n, I may find in gamma n, I may find beta n. This beta n is nothing but an handle. If I replace this beta n by an, I'm going to get gamma n minus 1. So it means that beta n is an handle in case of gamma n, and that is replaced by an. So we get gamma n minus 1. If we continue with this, then find an an minus 1 in beta n minus 1. That is, I'm going to replace beta n minus 1, which is here in gamma n minus 1, with an minus 1, which gives me gamma n minus 2. That is, gamma n, in case of gamma n, we replace beta n by an. In case of gamma n minus 1, we have replaced beta n minus 1 by an minus 1. So in gamma n minus 1, so when we replace beta n minus 1 to an minus 1, I got gamma n minus 2. In case of gamma n minus 2, I may find beta n minus 2, which is replaced by an minus 2, and so on. So if we repeat this, we get the starting symbol S. So this is called as a handle pruning. So with an example, so this is a given grammar, and the input string is ID plus ID star ID, which is a sentential form for this ID plus ID star ID look like this. So in the next step, we'll show you how this is handled using the shift reduce parser. That is how the handle pruning takes place. So in case of this right sentential form, so what we do is say here ID becomes an handle. This ID matches to the left hand side of the production, that is F. So ID is replaced by F. Now my next right sentential form becomes F plus ID star ID. Now F becomes an handle. You can observe that the red color shows that the handle which you are going to handle in every step. So this matches to the left hand side, that is T. So in the next step, F is replaced by T, and once again T becomes an handle. So T will be replaced by E. This becomes E plus ID star ID. Once again ID becomes the handle, that is F tends to ID. So my next step will be E plus F, that is E plus F star ID. So once again this F becomes an handle, so that will be replaced by T. We get E plus T star ID. So even though we find E plus T as an handle to replace by E, but we are not doing it because plus has got lower precedence compared to the star. That's why we are not replacing this E plus T by E. We keep this E plus T as it is. Handling this E plus T, we are handling this ID. ID is replaced by F. So in the next step, it becomes ID is replaced by F. Now T star F becomes my handle. T star F will be matches to the left hand side of the production, that is to T. So my next grammar sentential form becomes E plus T. Then E plus T becomes an handle for me. Then it gives you E tends to E plus T. So then finally I get E and say that the string has been passed successfully because we are able to read the starting symbol E. So in case of this, as I mentioned earlier, handles are nothing but the red colors represent the handle. It's an example for handle pruning. So there's another way of implementing the shift reduce parser, that is using the stack. So we use the stack to implement this shift reduce parser. That is, there are 4 possible actions of shift reduce parser action. That is, one is shift. The next input symbol is shifted onto the top of the stack. And in case of reduce, replace the handle on the top of the stack by the non-terminal symbol and accept whenever we read the starting symbol of the given grammar, then we say that the string has been passed successfully and we say that successful completion of the parsing. In case of unsuccessful case, that is, if we're not able to generate the starting symbol for the given input string, whether that string cannot be passed by using this particular grammar, we say that there is an error in the given grammar. So initially, the stack just contains only the end marker, that is the dollar. The end of each input string is marked by the end marker dollar to make sure that the string has been ended with dollar. So coming to an example of this stack implementation of shift reduce parser, I'll show you an example how it works. So in case of this, you can see that initially my stack consisting of dollar and my input string is ID plus ID star ID. Now what I do is I'll show an action part also. Since dollar is on the top of the stack, I'll shift ID onto the stack. Now ID is on the top of the stack, then this ID becomes an handle. So we'll be reducing this ID to F. So action part shows that F tends to ID. It means that ID has been replaced by F. My stack will have dollar followed by F and my input symbol is plus ID star ID dollar. Since F is matches to the right hand side of the given production, F will be replaced by T. So it becomes dollar $T. Still my input remains as plus ID star ID. Once again, my T is matches to the E tends to T. That's why we replace this T by E. So we get E in place of T. So once again, my stack becomes dollar $E and plus ID star ID followed by dollar is my input string. Since E doesn't matches with any of the right hand side of the production, we shift plus onto the stack. Then my stack becomes dollar $E plus. Once again, I'll shift ID onto the stack. So once again, E plus ID. E plus ID doesn't matches to the any of the right hand side of the production, but ID matches to the F. So we replace this ID by F. My stack becomes dollar $E plus F. Once again, my F matches to the right hand side of the production, that is T tends to F. We replace F by T. It becomes E plus T. You can just observe that even though E plus T matches with the right hand of the production, we are not reducing it to E because plus has got lesser precedence compared to the star. So what a shift reduce parser does is, before it checks what is the precedence of the operator in the stack and what is the precedence of the input string. If the precedence of the stack, the operator which is there on the stack has got less than the precedence of the operator of the input string, then it remains as it is. It is not going to be reduced. So since star has got higher precedence than plus, star will be shifted onto the stack. But it becomes E plus T star. Once again, we shift ID onto the stack. Once again, it becomes E plus T star ID. Once again, ID matches to the left hand side of the production, that is to F. So ID will be replaced by F. So you know that T star F matches to the right hand side of the production. T star F will be replaced by T. So then it becomes E plus T. So E plus T matches to E. It will be replaced by E. Finally, you get E, that is the starting symbol. The same thing has been shown as a parse tree. You can just observe that the given string is ID plus ID star ID. So you can just observe that first thing what we did is ID is replaced by F. F is replaced by T. T is replaced by E. Once again, once we complete this E, what we did is we pushed plus onto the stack. Once again, we took the next ID. That is, next ID has been replaced by F. F has been replaced by T. Once again, we did not convert this as E plus T into E because plus has got lesser precedence compared to the star. So what we did, we pushed star onto the stack. After that, we pushed ID onto the stack. ID has been replaced by F. Once again, after this, we converted this T star F to T. Once we get T, then we converted this E plus T into E. That's how you are going to generate the parse tree from bottom to the top in the reverse order.